Sorry, it's gonna have to come off. Here, breathe this in.
You're probably wondering how he got to this point. Let's roll it back a little bit.
Hi, Kiara Moore here.
And the hotter of the two, Rusty Bridgers.
Anyway, we're here with the official chemistry of Dummies Crash Course. Today, we're going to talk about a very specific chemical reaction. Well, to start off, we kind of need to define what a chemical reaction is, right? Well, for those of you who don't know, a chemical reaction is a process that involves rearrangement of molecules or ionic structures of a substance as opposed to a change in a physical form or a nuclear reaction.
This means that a chemical reaction is something that changes the chemical structure of the substance. Like, for example, combustion. Combustion causes something to burn or ignite, and it changes the molecular structure of something. Combustion is one of the many different chemical reactions that can occur.
Now, you're probably wondering what she was just breathing in. Well, here's where ICAP comes into play.
I'm just here to get the money.
Okay, no. As I was saying, you're probably confused about what you just saw, but don't worry, we're here to help. What the poor soldier was breathing in is called chloroform. It is, if you couldn't figure out already, a chemical reaction.
This reaction occurs when you take acetone and bleach, and you take these two very dangerous chemicals and mix them together. Chloroform's fancy chemical name is trichloromethane. This is a liquid, non-flammable chemical.
So it kind of would be like a deadly killer. Side note, awesome Halloween costume, chloroform.
Can you let me speak?
Sorry.
Yes, it is a deadly killer, but chloroform may fool you with its pleasant odor and pleasant taste because it's 40 times as sweet as sugar.
Funny thing is, chloroform is used in many different capacities. I mean, you can clearly see the example from the beginning of the episode. Chloroform was actually used back in the day around Civil War times as an anesthesia, although it did have some problematic side effects.
Chloroform is a very dangerous chemical that can hurt many parts of your body, but as shown in the simulation, it can be used to knock someone out cold. What happens is that the smell of chloroform enters your body and the compounds in this deadly combination go down to your liver, where a severe overdose can seriously damage it, causing blood flow to falter in your bloodstream. But chloroform doesn't stop at your liver. Oh no! Chloroform impacts your blood vessels, pancreas, and kidneys. This stuff can literally stop your heart.
Guys, chloroform is a serious chemical reaction with a lot of negative side effects. But you have to think yourself, why in the world would they use it as anesthesia back in Civil War times?
Maybe the doctors just felt like it was a lost cause. I mean, I know I would.
Wait, what? No, Rusty, no.
Truth hurts, I guess.
Anyway, not only did they use this as anesthesia back in Civil War times, as mentioned before, but we also have to ask yourself, why did people think it was a good idea to put chloroform in?
Cough syrups, liniments, sedatives, and pain relievers. Okay, let me give you the rundown.
Please stop. I think I got this one. Chloroform was seen as a good thing before they realized that it could kill some people. During the Civil War, it became very important medicine for the military doctors who performed tens of thousands of amputations and other types of procedures for wounded Union and Confederate soldiers.
People thought that it took action faster and saw that it was non-flammable. This means that it was able to knock people out fast, and it was faster than any other anesthetic at the time. This created some sort of stereotype about chloroform that it was the best anesthetic around. Okay, so we covered the main grasp of what chloroform has done, but what about the specific chemical reaction? What happens there?
Wait, aren't we supposed to tell the answers instead of asking the questions?
It's rhetorical, Kiana.
I didn't know.
Anyway, I'm sure you've heard of different types of chemical reactions, but in case you haven't, me and Jennifer will cover the different kinds of chemical reactions and give you a recap.
Oh, sorry, Rusty. I didn't see you there. Yes, chloroform is useful and chloroform is deadly, but the magic is all in the reaction.
Magic?
Yeah, totes. Acetone C3H6O is oxidized by bleach.
And bleach is CaClO2.
And this is caused by acetone heating up with bleach power to create trichloroacetone.
The decomposition of trichloroacetone with calcium hydroxide or an alkali then occurs. The initial heating basically sweats away the bonds that hold acetone together. Crazy how this factory work happens at such a small level when I can't even get out of bed on a Saturday.
Hey Rusty, guess what?
What?
Don't you think it would be pretty crazy to witness a chemical reaction before your eyes?
I mean, I guess so. It's not a normal thing to do.
Well, the production of chloroform is caused by a very visual reaction in which many signs of a reaction may occur, such as bubbling, color change, and odor change. The gases released by the reaction is dangerous itself, but once you sniff it, then say goodnight.
So in a sink or replace reaction, AB plus C becomes A plus CB. The B switches places with the A and goes with the C, like your nasty cheating husband replacing you with some other woman.
Yes, single replacement reactions are important, but double replacement reactions are what really matters. So buy single replacement reaction, and hello, double replacement reactions. As you can see, we have AB plus CD, and these reactions are going to switch out with each other, and the D and A are going to go together, and B and C are going to go together. So the reaction would be have a product of A, D plus BC. And it's kind of like how when you get replaced because your husband's having an affair, but plot twist, you were the one cheating too.
The next question you should be asking yourself is, if you haven't lost it already, what about balancing the equation?
I mean, what's so important about balancing equations? Well, the purpose of balancing equations is used to follow the law of conservation of mass. That means there isn't more mass on one side and it would be equal.
Which in English means you didn't add or lose any electrons.
Let's use aluminum iodide plus mercury chloride as an example to explain how to balance the equation. As you can see, right here we have aluminum iodide, mercury chloride, and in order to get the product, we need to use double replacement. As we stated earlier, we know how to use double replacement. So we would switch the I with the mercury, and chlorine was switched with aluminum, as you can see over here. Now, next we would have to list down all the certain amount of atoms for each element. And aluminum has 1, as you can see right here. It doesn't have any subs. And iodine has 3. Mercury has 1 because we can tell that there's a 1. It's already known. And chlorine has 2. Now on this side, with the products, we have aluminum, which has 1, which is an understood 1. Iodine has 2, so we put it over here. And mercury has 1, and chlorine has 3. So right now, the equation isn't balanced, so we must balance it ourselves. And in order to make it balanced, we know that iodine has a common factor of 6. So to make this 6, we need to have a 2 here, which makes a 6. But it also affects the aluminum, which makes a 2, because you're multiplying. Right here, in order to get the iodine to 6, we must multiply it by 3. So we add the 3 here. So it also multiplies to mercury. So 1 times 3 is 3. And the iodine would be 6. As you can see, the equation still is unbalanced. So next we have to do mercury. And in order to have it to get it as the same as 3 for here, so we must multiply this mercury by 3. So it would also be 3 here. And it would also affect the chlorine, which makes the 2 a 6. Back to over here. In order to make the chlorine and aluminum the same as these two, we need to multiply it by 2. So we can just add it over here, and we get 2 and 6. So right now, we have equal balance equation. So this would be our balance equation total on top. Now let's move on to electrolytes, because they are really starting to get this place sparky, if you know what I mean.
What are they? Electrolytes are substances that ionize in aqueous solutions and break apart into cations and anions to create electricity.
There are weak electrolytes, like Seth, and then there are strong electrolytes, like me, and non-electrolytes.
Like me. The substance chloroform is a non-electrolyte because, unlike other electrolytes, it doesn't release electricity when it breaks apart in solutions, like a total disappointment. Covalent compounds are commonly non-electrolytes anyway.
Now that we know a whole lot about chloroform, where did it come from?
Your mama, where do you think it came from?
What? Now, let's move on with James Young Simpson because he sure is ready to come on up and tell us all he knows about chloroform. You might be thinking about that really awesome doctor who pioneered chloroform. Well, you're right. He is someone special to remember, especially since he knocked himself out with his own discovery. I mean, I wish he could pass some on over here and let us give it a whiff. Am I right? Anyways, come on up, Mr. Simpson.
Whoa. Don't drink. Oh, she drunk it.
Good morning, Mr. Simpson. My name is Jennifer. How are you on this lovely day?
Good day, Jennifer. I got you some chloroform. I heard you talking about it earlier.
Yeah, thank you.
No problem.
Correct me if I'm wrong, but is it not true that you were on a search for something better than ether? For an anesthetic during surgery or childbirth to take away the pain from the patient?
Yeah, that's absolutely true, Jennifer. Ether is very irritating, especially since it affects the body very slowly. It also has this super foul smell that causes irritation to the lungs and could possibly light on fire, which was very risky for surgeons who work by candlelight.
Oh man, I guess ether really is infuriating.
Yeah, it really was. For a period of time, it seemed as if chloroform was very useful at getting the job done, but a lot of people didn't expect that it would be so deadly. It was even used to poison those in-laws that just wouldn't shut up.
That is very frightening to think about all those people who died over this chemical reaction. Let's take a moment for them. Moving on, could you please explain the experiment you did with your 2 lab assistants?
Yeah, I believe I can. The purpose of the experiment was to test compounds that would do a better job than ether, basically. To make sure that the compound worked, we tested it on ourselves to see the impact and effects. Until this day, I will always remember. On November 4th, 1847, we put our faces into the vapor rising from the chloroform, and in less than 2 minutes, we were gone. Completely knocked out.
Oh, so you mean you KO'd?
It was a very serious. It was a serious situation.
Come on, don't you get it?
You're laughing about.
Moving on.
I don't appreciate that at all.
Sorry. Well, could you please tell us what happened after the 3 of you woke up, and how long had you and your lab assistants been unconscious?
We woke up about half an hour later. When we woke up, we were super lightheaded and very dizzy.
After being knocked out by that reaction, were there any traces of the chloroform causing any harmful effects?
At the time, we weren't aware of any harmful effects, mainly because we weren't physically hurt. I could remember thinking, this is going to change the world, and I can assure you that it definitely has, because it's killed thousands of people.
It seems that chloroform is indeed a very dangerous chemical reaction. I am certainly glad that it has been banned from being sold in drugstores or anywhere else because it is truly harmful and deadly. I would certainly not want to be the one to die that way. I'm sorry, but I believe that's all we have left to discuss. I would like to thank you very, very much for joining us and bringing this delectable drink.
Not a drink.
We appreciate you for being here, really. And I hope you have a great day.
It's been an honor to be here and be able to spread my discovery, which is the bottle you've been drinking this whole time.
Oh, really?
Yep. Anyway, thank you. Thanks for watching.
So I told the guy, I was like, you eat the hot dog with chili or eat the cheeseburger with cheese. So I watched cheeseburger. Wait, are you recording?
You see the camera, don't you?
Yeah, sorry. Might have been the chloroform in the air. Knee slapper. No? Okay. As you can see, the chemical reaction of bleach and acetone really came together to create a different solution.
One that can amaze you, but also drug you.
Okay, so here's a recap of what we learned in today's episode. Chloroform is a reaction of acetone and bleach.
What chloroform is used for, and how chloroform is chloroformed.
How it damages the body and how the reaction occurs.
How it was discovered and the history of it all.
And how it's used to kill people.
Don't forget to leave a big fat like and subscribe.
And please, kids, don't try this at home. Thanks for watching!